Hi, so this video is about exporting this mesh that we created here into Abaqus from MATLAB. So there is this function that I've created. It's called save to Abaqus input file, and what it does is it takes a couple of input parameters and it saves it to a file called a input file. And you can see if I bring this in here, this is the type of file that we will get. We will get basically whatever we want, but now the functionality is that we will get the basic mesh, and that's basically just the node connections, all of the coordinates, the points, the nodes. This is what we have here, the node, and the element connectivity, which is further down here. So we have the element here, we have a certain type of element, and then all of these, every row is one element. And then optionally we have two sets here, two node sets and sets that are named boundary conditions and loads here. Yeah, and let's see how we can create this thing. Obviously you can do it manually, but well, the larger your mesh gets, the more work you will have to do, right? So this function deals with all of that. Let's see how it works. So I have this script here. It's just main.m, and created the mesh function here. This is your first assignment to create. So once you have that, you can visualize it using the tools I've showed you earlier. And then you have to look at how this function works. How can you take your data that you have here, your nodes and your points or vertices or nodes, and throw them into this function to create this this output. So I wrote documentation for this function. So if you right click and select help on this function, or press F1, you will get this box here, the documentation. So how does it work? Well, the function has two mandatory parameters. One is the vertices and one is the element sets. So let's go through it and see how this works. So the vertices is just what you have here in your P, right? So let's see if we can bring in the command window to look at it. So well, I've created a struct here just to visualize this easier, and then it's here. So P is loaded into this mesh struct with the field P. So if we just take a look at it here, we can see that we have nodes, which is a 250 by 4 matrix, and we have our coordinate matrix, which is P, which is a 306 node by 2. So it's 2D set, right? And we have ln h, but that's out of the scope, so just ignore that. All right, so vertices is then just P. So you throw that in here. And then element sets is interesting because, well, you can actually have lots of element sets, right? You can have several types of elements in your input file. You can have triangles, you can have quadrilaterals, just as a basic example. It can be much more complex than that. So we can't just throw in one list. We have to be able to throw in several. So in this example here, it's you create the element set as a array of structs. That means that it's an struct, but it's also, you can have several structs inside. So this element set here is just the array of an struct is just created like a standard struct. It's just that you add the parenthesis right before the struct field. And in this case, we indicate that the first element of this element struct is well, 1, and you type the type as a string, and the type is the element type, and there are lots of element types. I've actually googled this and found a document here, a PDF. You just bring it in here. Try to fit it into this recording box. So the plane strain elements we have here, this is just the standard triangle plane strain element, and then you have a 4-node bilinear, and then you have all of the different types of elements here, fully integrated and reduced integration. And you have 6 nodes, you have up to 8 nodes, bi-quadratic elements here, and you have lots of these. So yeah, so I made this function so that it's general. We can use any element we like here, and we can input the actual sets here. So this is your matrix, right? Your node matrix from what you have created here. Nodes, that is the nodes. So you put that in here, and you're all set, because you only have one element set. Okay, so that's basically what you have to input here. Then you have optional parameters, and those are inputted like the standard MATLAB type of optional parameters. It's pairs. So you put the name, and then you put the actual value. So for example, it looks like this. If I move this box out of the way, node sets, for instance, is such a optional parameter. So let's look at node sets. What is node sets? Well, it's a struct array again, containing the fields name and node sets. So if we want to say that we have a set of nodes here, and we call that boundary, and we show that in this set we have the node 1, 2, 3, 4, 5, 6. We can do that. We can input that here, node sets in the first element of this struct array. We have the boundary, and then in the second one we have something called load, and that's node 14, and we just send this in using node sets and node set here. So this is the name of the property, and then the actual property value. And the another optional parameter is the file name, and here we can specify directly to put this into the temp folder for Abaqus to see directly. Otherwise we have to manually copy it there. I'm not sure if you have seen this. I moved it out of the recording box. Yeah, so node sets. Also job name. By the way, node sets by default is just empty, so you don't have to write anything here if you don't want. You can just leave this empty, and then node sets will have to be created manually later. But if you already know how to find the node sets, you can just do it here, and yeah, you don't have to do it in Abaqus. You can just select it by these names that you have specified here. Okay, so that's how this works basically, and let's just run it and see what happens here. So just press run, and I get my figure here. And if I find the command box, this is what happens. It says that this many bytes have been written to file. So let's find the file, and here it is. So this is Notepad++, so it has detected that it has been changed, and let's reload it, and this is what we have here. Here's the file. It's a specified folder, and this is what we have. And let's see if we have if all of the nodes have been written. So we have 306 nodes here, and we have how many elements? Well, maybe it's hard to see because compared to, so that the first number here in the nodes is the actual node number, and then we have the actual point here. So this is not a 3D point. This is actually a 2D point. It's just the numbers attached to it, and that's how Abaqus works, because these don't need to be in order. They can be in any order. And then this is just a reference for the elements. So point 14, it will go up here in the list, find 14. Where's node 14? There it is. And we just select this one. Okay. Yeah, so let's just verify this. We have 306. So let's go in here. Actually, let's find the nope, that's not gonna help us. Yeah, well, actually it is. Let's take a look at mesh or nodes. So we can just do size nodes. It's not nodes, it's p, size p. So 306, was that right? I don't remember. Yeah, 306. So that seems to be right. Okay, that's basically it. That's how you export your mesh from MATLAB to Abaqus.